Students, can you see my screen?
Yes.
Yes, ma'am.
Okay, thank you. Okay, so today's session is about procedure abstractions, how to build abstractions with procedures. Okay, so this session is about how to calculate square root of a number. Let us take that example and we can better understand what is meant by procedure abstraction. Okay, so how will you calculate square root of a given number? Students, please, what is the method you will adopt? How will you calculate square root of a number? So if you take a calculator, a normal calculator, you can find out addition, subtraction, multiplication, division, square root, sine, cos, all the things are built in inside a button, right? If you are clicking plus, you can add it, right? So if you are clicking on some number and a square root, you can find out a square root. Okay, so now this is the building block. Actually, it is provided to you and you don't know what the details of the square root, right? So now let me take okay, so for example, if you take square root of 4, what is that? You can easily say 2. Square root of 9, you can easily say 3. What is square root of 7? What is square root of 7? Students, are you there? Can you hear me?
49, ma'am.
Sorry?
49.
Square root of 7. Square root
Oh,
of 7.
sorry,
Yeah. Yeah. Okay. Understood. So square root of 7, how to find out? I know square root of 4 is 2. I know square root of 9 is 3. So I will have a guess the square root of 7 will be from 2 to 3. Yes. So in our initial courses, first year courses, you might have studied about Newton's method of finding the square root. Can you recall that one? Yes. So now, what is meant by Newton's method? How will you calculate the square root? Anyone of you? Students, please be interactive. Otherwise, the course will not be useful to you. How will you find out square root of a number using Newton's method? Newton's method you have studied, right? You will have an initial guess and you will have a function. Apply the initial guess to the function, you will get another value. Then that new value will be considered as a guess, and that guess will be once again will be applied on the same function, right? You will repeat it till you are getting a satisfied result, right? So it's the iterative process. Yes or no? I think I hope that you understood what is meant by Newton's method. Students? Okay, so let me play another video for you in order to recall. Let me share it. Can you see a YouTube here?
For finding the square root. So suppose I want to know the square root of 10.
Students, can you hear this?
yes,
Yeah,
ma'am.
yeah. Let us see. See, we would like to find out the square root
I know
of
that
10.
the square root of 10 is between 3 and 4, so I'll just use 3 as my first guess. You could have used anything as your first guess, but it's better if you use something close to 10, and I like to use the thing that's smaller than it. Now, to check if it's right, I could do 10 over 3 is equal to 3 1/3. And since 3 1/3 is not the same thing as 3, that means that 3 was not the square root of 10. 3 was smaller than the square root of 10. 3 1/3 is bigger than the square root of 10. And our new guess is going to be the average of the guess from before and 10 over that guess. And I like to simplify this, get common denominators. So get 9 over 3 plus 10 over 3 over 2 is 19 over 3 over 2 is 19 over 3 times 1/2 equals 19 over 6. 19 over 6 is a pretty good approximation for the square root of 10. But we can do better. If we take the most recent sort of approximation, 19 over 6, and if we do 10 over 19 over 6, and take the average of those two, I'll get an even better approximation. It turns out that 19 over 6 is a little bit bigger than the square root of 10, and 10 over 19 over 6 is a little smaller than the square root of 10, so the average is going to be closer to it. I'm going to simplify this fraction first. I'll change this. 10 over 19 over 6 is the same thing as 10 times 6 over 19, which is 19 over 6 plus 60 over 19 over 2. The common denominator is going to be 19 times 6, which is 114. And this becomes 19 times 9 and 6 times 60. That's with common denominators. This ends up becoming 721 over 114 over 2, which is 721 over 114 times 1/2, which is 721 over 228. That is very close to the square root of 10, which is 3. This one's 3.16228, and the actual square root of 10 is 3.162277. So very good. And if you have the heart for it.
Okay. So just a minute. Yeah. So I hope you understood what is the process involved in Newton's method for finding the square root. Can you tell me? After seeing the YouTube video, students, what is the procedure? Okay, let me go to the subject. Okay, I only teach you. Okay, please be quiet then. Okay, so now what is our problem? The problem is finding the square root of a given number. So in the mathematically, I can write square root of x equal to the y such that y is greater than or equal to 0 and y square is equal to x. Okay, this is the mathematical statement. Okay, so now I would like to write a Lisp procedure. After all, we are learning the Lisp and how to write a Lisp procedure for finding the square root of a given number x. Okay, I will write a procedure like, see here, define square root of x. So sqrt is the function, x is the variable, and inside I will write the body of the function, and the body of a function is the value of y, and what is the condition? Actually, y is greater than or equal to 0 and y squared is equal to x. Whether I can achieve the square root of a given value by this procedure, students, this particular procedure will be helpful for finding the square root of variable x. Students, can you tell me please? No, why? Because actually this is nothing but interpretation of the given mathematical expression. I have a mathematical expression, but I am defining it by this procedure. But this is called as a declarative knowledge. Declarative knowledge will not be helpful, but after all, declarative knowledge is useful for defining something, declaring something. Okay, so some form that is in the list form, we can able to define a mathematical expression. Okay, so this is nothing but this particular procedure. What you are seeing is called as a declarative knowledge. But we want imperative knowledge. What is meant by imperative knowledge? Imperative knowledge is nothing but how to do the things, how to find out the square root of a number. That is called as the imperative knowledge. Okay, so declarative knowledge is nothing but what it is. So what is square root of x? You can say okay, what it is, but it does not say how to perform the operation, how to do that. Okay, so how to do that is very important when we are writing the procedure. That is called as a imperative knowledge. You have to write a procedure which possesses a imperative knowledge. Okay, so now so we are taking the problem square root and we are going to solve it by a Newton's method. So now for example, I told that square root of 4 is 2, square root of 9 is 3, so it is all an integer. Okay, no problem. But the square root of 7, what will happen? It can be your number of floating point, right? It's a irrational number. Okay, and square root of, I can say square root of a prime number. 7 is a prime number. Yeah, so 11, square root of 11 is a prime number. So while finding the square root for a prime number, you will end up with a what? Relational, real numbers, floating point numbers are irrational numbers. Right, so the irrational numbers, when the answer for square root of 7 is the irrational number, that means after the point you have multiple digits, right? So while saving a multiple digit, it will occupy a space, right? So we are going to write our own method by which we can restrict the number of decimal digits after the decimal point. Okay, so now here how the Newton's method work, how the Newton's method is going to work. But by this Newton method, what we are going to do is we are going to find out the approximation of the square root of some number. It is a successive approximation. Successive in the sense what? Repeatedly we are doing something, some operation, and finally we arrive to a approximation to the answer. It is not the equal square root of something. We are not getting a equal number, that is the correct number, but it is the approximated number. So because it is a floating point, it may have some 100 number of digits after the decimal point, but now through this method we will be restricting it. After the decimal point, we may have some few number of digits. Okay, so that is called as the approximation. So by the Newton's method, we can only calculate the approximated value, approximate result. Okay, so whenever we have a guess, so there are two important steps involved here. Whenever we have a guess y for the value of the square root of a number x, so we have given a variable x, and for which we are going to find out y, and I will have an initial guess y. So how to find out a guess for a for the guess for a square root of x? So given a number, we know the previous and the next non-prime numbers. For example, square root of 7. So the square root of 7 is in between 4 and 9. In between 4 and 9. So square root of 4 is 2 and the square root of 9 is 3. So square root of 7 will be in between 2 and 3. Right, so we have an initial guess. I may start with 2.1, 2.2 like that. Okay, so we must have an initial guess. You must have an initial guess and proceed further. Okay, so what we are doing in each and every step, perform simple manipulation to get a better guess by averaging y. Y is what? It is my guess, and with x by y. What is x? The number. That is radicand I can say. So square root of x, that x, right? So radicand divided by the guess. And what we are doing, we are performing a average value. So average of y comma x by y we have to compute. That value will be the new guess. Will be the new guess for the next step. Okay, so let us take some example here. I have to find out square root of 2. I have to find out square root of 2. So my initial guess is 1. Okay, and I have to find x by y. This is y, and I find out x by y. What is x? X is 2. 2 by 1, it is 2. Okay, and after that I will find the average of both. What is average of 1 and 2? So average of 1 and 2, 3 by 2, it is 1.5. This is the first iteration. That 1.5 will be the new guess for the next iteration. So guess is 1.5 and I'm finding x by y. X is 2, 2 by 1.5. I will get 1.333. So 1.33 plus 1.5, the average of this is 1.4167. And take this for the as a guess for the next iteration. So 1.4167 and 2 by 1.4167. Okay, you will get 1.4118. Now you find the average of this number and this number. You are going to get 1.4142. And the 4142 will be considered for the next iteration and repeat the procedure. And if you find the guesses, the initial stage, that is the previous stage, 1.4142, and in the next you are also getting the same 1.4142. So now you can stop also, right? Or you can continue and experiment whether you are getting a different value or not. Right. So I hope you understood how the Newton's method is useful for finding out the square root of a number. Okay. So this is the process. Okay. We are defining the process, but how to write in terms of a procedure, in terms of Lisp procedure, I can say. Okay. So let us go to that. So what is the aim of the session? We are all able to understand how to write a procedure for finding the square root of a given number by using Newton's method. Okay. Hello? Can you mute yourself, student? Someone is unmuted. Okay. So now if you take this one, we are can you see my PDF? Can you see my PDF?
Yes, ma'am.
Yeah, thank you. So now we will write a procedure using the Newton's method. Define sub underscore SQRT is my procedure name. And for this, we are going to pass two arguments. One is a guess, that is y, and another one is a x, that is a radicand. Now, inside, if you look at if good enough, guess x, if the guess is good enough, then return the guess. Otherwise, you have to call the same function by improving the guess. Okay, by improving the guess, you are calling once again the same procedure. So, for this procedure, how many arguments are there? Guess and x. Okay, so if you look at this one, sub str, and one argument is the result of this function and x is passed over here. Okay, now this is very abstract. What is good enough? Okay, what is improve guess x? What is improve function? What it does, we don't know. All right, so this is the upper level part, and let us go inside how the improve will look like. Okay, so let us define a improve. Improving the guess, that is for the next iteration we have to find out the new guess. So how to find out? So that is define improve is a function. We are passing guess value and x. So what is that? How will you improve? Improve is by the average of the guess, right? And x divided by guess. I think you understood, right? X divided by guess and then guess. The average of these two values will be the next guess value. Okay, so now here, if you look at the average, where is the average? The system does not know what is that average. We have to define, we have to tell how to compute average. So we have average, and for which there are two parameters. So if you look at here, one parameter is guess, another one is the result of x by guess. So that will be substituted for y. So average of x, y is computed here. So x plus y divided by 2, this is the composition we have written for defining average. So now we know what is improve. Improve has average. Average, what is the logic of average also mentioned here. So now some more thing is not understandable. So that means what is meant by good enough? We have used good enough in our previous abstract. So what is good enough? Let us define that. Good enough. So the define good enough is a procedure, and it is going to take guess and x. as an argument. Here what we are doing, what we have to do is here approximation till which iteration you have to go further. Okay, so till that is what will be the last iteration, when the iteration will be ended, that termination point we have to know, right? So the termination is calculated like this: square root of x is y, yeah, right? So square both sides, so y square equal to x, so y square minus x, and then absolute value of y square minus x is less than 0.01. If it is, we have to stop the iteration. So this is the one. So define good enough, and we are just writing here what we are writing, that is square of the guess. Square of the guess is what? Y square, and then minus x, yeah, minus x, and take the absolute value, yeah, take the absolute value, and then that absolute value is less than 0.01. Then you have to terminate. I can say it is a very good guess, we can terminate. Okay, it is good enough. So the good enough is a procedure which we are defining like this. What is that? It is absolute of y square minus x is less than 0.01. Okay, so now if you look at the program, the earlier program what I had is like this, and each and every part is defined by me. Good enough, I have defined. Improve, I have defined. If you look at the improve, there was a average, that also I defined. And if I look at square, right, y square, the square also has to be defined. Okay, so the square is defined, and finally our procedure definition is over, and we will call the procedure. So how to call the procedure? My procedure name is SQRT, and then 9 I am calling. I will just give the output. Okay, for the square root function, can I use this parameter for the same function what I defined? Can I use this parameter? Yes, it is possible. The Lisp, what it does is the inner bracket is evaluated and that result is passed as an argument, right? Can you call the square root as a parameter for the same function? Say here square root of what? Square root of 2 plus square root of 3. Then for the result you find out the square root. That also possible. Square root of 1000, it's also possible. Square, provided square is written by you. Okay, so this square root, once you define, it can be acting as an argument. Okay, so that function you can also pass it as a parameter. Okay, and for the parameter of the SQRT, you can have an expression or you can have a simple value. So the Lisp knows how to evaluate this composition, how to evaluate these arguments, everything the interpreter knows it. Okay, so this is and for this I would like to show you the same program. Can you see this Dr. Racket environment? Can you see? Can you see here?
Yes, ma'am.
Yeah, so the same procedure I have just written. I have average, I have a improve, I have a good enough, and I have a square. Okay, and I have a SQRT ITR. This is my main function, this SQRT. If I am putting a cursor over there, you can have a pointer which will show you where the particular function is available. Something is processing. Yeah. So now if I put a pointer square root SQRT ITR, it will show you where and all it is available. Okay, good enough is available there. Improve is available upper side. And yeah, so now I just call square root of 9. Even I can call with the previous statement square root of SQRT of something 2 into 5. How to write 2 into 5 here? Brackets are very important. So I may get the answer, right? So you can even have a composition, even this argument can be another square root, whatever may be, it is executing. Okay, I hope that you understood this finding the square root of a number using the Newton's method, right? So now procedures as abstractions. Now come to the point. When you will say the procedure is following the abstraction, we have written an abstract procedure when you will say, right? So for the abstraction, we no need to know the internal logic. For example, I have here square root of x. I'm just calling square of x. I will call. I will not know the logic behind it. So what is the logic you have written? You might have written star xx, or you might have written this logic, that is finding in the logarithmic form. That is log of x and then exponent you will apply, right? So there are many procedures available, okay? And the logic is not known to the higher level abstraction. You just treat this as a black box. Okay, so square of x, the logic, internal logic is not known. I just know only the procedure and the number of arguments what I have to pass. Okay, so the logic may be anything else. Okay, it is a programmer dependent. So whenever I am writing a square root function, I will not bother about how the square function is implemented, right? How the improve function is implemented, I don't know. Okay, after all, I will just call sqrt. Okay, this is called as a procedure as abstraction. So if you look at this one, the previous example, we had SQRT. We are just calling SQRT, but internally it is calling SQRT ITR, and that SQRT ITR is calling good enough. Good enough is calling square, absolute, and again improve average. These things, I can say the square root. I can say square root ITR, it is nothing but a mutually exclusive procedures. It is a composition of mutually exclusive procedures. Okay, so the square root, by just calling the square root, and I know the square root is going to call SQRT ITR, but I don't know, I may not be knowing square root ITR will call improve, will call good enough. I may not be knowing it. Okay, so the whole procedure is decomposed into sub procedures. So the sub procedures are square, ABS, average, etc. Okay, so this kind of programming is very important, right? So to the third party people, they only know what is the higher level. They may not be knowing what is internal to it. It is not required at all after all. Okay, so this is one way of writing the program, right? So the bigger problem is divided into or decomposed into sub procedures, right? And we, by knowing only the block box name, we can do the wonders. Okay, so next we go for the concept of bounded variables and free variables. When you will say the variables are called as bounded, when you will say the variables are free variables. Okay, so let us look at one example. There was a procedure good enough. Good enough is going to take two arguments. Okay, guess x. Okay, if you look at the logic inside, what is that? Less than, absolute, minus, square x, guess something is safe, right? So now what happens is, which variable is called as a bounded variable, which variable will be called as a free variable? Can you extract, the answer is given, can you extract a logic when you will say a particular variable is called as a bounded variable? Any answer from the students? When you will say particular variable as a bounded variable, when you will say it is a free variable, how will you identify this? Students?
Some parameters are
Sorry. Yeah, tell me, you are not audible actually.
ma'am, are the parameters the bound?
Yeah, bounded variable is nothing but a formal arguments. The formal arguments are bounded to the logic of the procedure. That is why the guess x all are called as a what is that? It's a bounded variable. Okay, so bounded variable guess and x are bounded variable. If you look at this one, so what are the free variables? Okay, less than I can use anywhere, right? ABS I can use anywhere. Square is not bounded here, but square, given a square procedure, it can be used in any other procedure. It is not bounded to the good enough alone. Okay, understood. So the formal arguments which are listed to the procedure is called as a bounded variable. Why? Because the formal variables are bounded to the logic of the particular procedure. And other variables in the body logic, the body section is called as a free variable. Okay. So this much. With this, I wind up the session. Actually, this particular subject, something you say, I know, but sometimes, this something like, sometimes if you're not understanding the beauty of the internal logic, you know how the interpreter is working, then it will be, you will get bored. Okay, so please don't go to the second way. Okay, make it interesting. Okay, after all, you are learning the internal mechanism of a particular logic. And this can be the first course for any BTech engineers, but you have been provided with procedural language and then object-oriented language. Finally, you are coming to the functional-oriented languages. Okay, so that is why you will get bored. But in other universities, MIT and all, this is the first course for teaching the languages. Okay, so as I already said that the problems, any problem in the real world can be solved in two ways. One is by using a recursive version, another one is by iterative version. Okay, I show you how to, what is the logic when you are going for solving the same problem, how to find out the square root of a given number using iterative procedure or iterative methods. Okay, so I show you just a minute. There is a procedure called as something. Just a minute. In Geeks for Geeks, I can able to find out. I'm in a maximized state. Okay, just a minute. Yeah, I go here. Finding square root of a number. Yeah. So you can see a program. This is, if you look at here, can you see the Geeks for Geeks in your screen?
Yes.
Yeah, so if you look at it, this iterative, how many lines of code is occurring? See, right? But while writing in a recursive version, the number of lines are reduced. But also the hint is by using the recursive, calling the function repeatedly, you are going to perform an iterative task. Okay, so the iteration without using the control structures, you can perform an iteration. That is by just calling the procedures repeatedly. So that is the takeaway of this particular session. So for finding the square root of x, you may also write the while struct. See, you can see the while construct, right? By using the while also you can solve it, but without control structures as well we can solve it by using the recursive methods. So that is the takeaway of this particular session. So in your free time, you just look at how to find out a square root of x by using the iterative method. Okay. Yeah, so same logic, Newton's method, if you look at, there is while of n, there is a count, and if you look at this one, the root 0.5 into x plus n by x. X is nothing but a guess, and n is a given number. So the average of this number is taken as a guess, but actually we are calling it as root. Okay, final root is nothing but our guess, right? And then we also perform the same operation, that is root minus x, absolute value is less than some number. Okay, and then break it and come out. So the same Newton's logic also can be written in terms of iterative version. So look at this. All operations we have done as well in our earlier programs by using recursion. So if you look at, there is a number 327 and there is a number L. L is nothing but 0.001. So this is useful for stopping our iteration and calling the square root function by passing N and L. And we come here. Okay. And this number N is assigned to X, and then you have a local variable, etc. This count is useful for how many times the loop is executed, repeated, and we are calling the root. We are calculating the root, and then for breaking, we have a if statement, absolute of root minus x less than 0.001. Then we are coming out, and after coming out, you will be returning the root. Okay, so the same logic is interpreted here, written as well by using the while control structure. Okay, so simple things we have elaborated. I have shown you a YouTube video how to calculate a recursive version of square root. Okay, and we have written a Lisp procedure, and I have shown you in a Dr. Arcade how to execute. Okay, and the iterative version as well. And also the concept of block box, that is procedure abstractions. The higher level procedures can embed lower level procedures, which are the details are not known. The logic is not known to the user, right? So what is meant by bounded variable? What is meant by free variable? Bounded variables are nothing but a formal arguments which are built or bounded inside the logic of a procedure. Other variables in the procedure is called as a free variable. Okay, so with this I will wind up. Let me hear any doubts. If you have, you can ask me.